Hello everyone. Today we are going to discuss about our book chapter optimization of hand motion recognition system based on 2D HMM approach using ABC algorithm. So first I introduce my team member, uh, Dr. K. Martin Sagayam, Assistant Professor of Department of ECE, and Dr. Jude Hemanth, Associate Professor of Department of CSE in Karun University, and I am Nitesh Yadav. I am studying in for CSE BTech of Karun University. So today our book chapter we are discussing about our aim is to develop the advanced gaming interface using virtual environment using without touching anything, and our aim is to recognize the system of using uh, motion, the motion which captures the image without sensing, which sensing the part. For example, an object which is moving from one part to another part, and which will sense the data, and it will detect by the using hand. So our aim is to uh, develop a virtual environment to establish a well defined stochastic mathematical approach of hand motion recognition system among the various gestures in the human body. So, in the hand gestures plays a major role of interact between the human and computers. So, as you say, the is this the gesture of the bodily actions which are communication without using of the words, and it will sense the data of the hand moving. So, it will the idea to propose the work to optimize the hand gesture recognition system using computer vision's machine learning pattern. So here we will go to the image processing algorithm, and which we will using for the uh, hidden Markov model approach. Last stage, the optimization, the stage of the sequence of the Markov model in the heuristic approach called the artificial B coloring algorithm, which will using in our part for the hand and image recognition system using optimization of hand motion recognition system based on 2D HMM approach using ABC algorithm. So our keyword is a virtual environment hand motion recognition system using 2D HML and artificial B colony algorithm. So our aim is to develop a gestures using bodily moving, and it will detect the data how it will move, and it will goes for the real virtual reality and gaming system. For the gestures are bodily actions which are used to introduce to communication without using the words. Hand expression can be used for creating gestures for interacting with the human and computer in virtual environment to make a system more reliable without using any mechanical devices or any touch with using the system. It will detect only the hand motion to detect only the virtual image, and it will develop what is the human interaction between the systems and motions. So it will recognize the system using the computer vision machine learning pattern recognition and image processing algorithm. It creates a better bridge between human and machine. So are the system which adopts the input devices to interact the system are which means are implementation parts of the system using frame. This is the R hand. So it will which will moves one part to the another part. So it will detect the system how the hand moves going on and how the hands will come in. So our objective is the advanced gaming interface using the virtual environment which is to establish the mathematical approach of the hand motion recognition system. So it will provide the major problems of conventional methods recognition in forward and backward using precision 1D HMM scalability and memory storage time consuming in training phase and testing phase. In real implementation of the optimizations of the hand motion is the motion will detect each and every part for the sensing of the motions of the hand gestures. So it will detect the gestures. So it is a framework which proposes across all the system. It will goes to the hand, and it will detect the data, and it goes to a database and it will store. First is the pre-processing part. The pre-processing which handles the data which will use to detect the R features is to handle the how it will process the images and it will goes to the part of the images and it will show the what hand motion is to detect and what hand is showing for the images, and it will detect the exact data and it will process the data in using pre-processing feature extractions. It will use to the feature will extract the data will be formed in the real implementation part of the form, and it will use to the human computer interaction using the hand motion recognition. So it will describe the hand motion recognition system, the virtual reality application, the four main stages. As compared to this, I told you the pre-processing, feature extraction, classification, performance measures, and optimizations. So here, edge detection technique is the location of the hand proposition from the entire image, which will complex a background by using four different types of operators such as Sobel, Pervit, Canny, and Robert. After detection, the hand position extract the feature vector discussed in the next step. So this is a framework of the proposed system, the performance issue, the performance measures of the how hand motions can be detected from the using hand gesture algorithm using the hand motion recognition system. So our aim is to motion will detect how it will be probably and interact with the human computer interactions. As I told the previous images, this is a database which will collect the Imperial College website, and it will the v shape left right and how the images will compare and how will detect the computer in the human interactions and the real image. So here the image processing as detections are so well. There are four types of operator: the Sober operator, Pirvit operator, Canny operator, Robert operator, and morphological filter. So it is the image gradients is the equations which we'll use in our part for using to hand motions, which is a real implementation part of the hand motion recognition system. So this is a gradient direction is given by, and this is the equation which will using and included in the real image, which will forms the database, and it will interact the data how it will come, and it will use the axes for x-axis and y-axis, which will use to the equation will part, and it will gradient in the perpendicular of the edge. So edge detections, this is a Sobel operator and Pervit operator, Robert operator, Canny operator. This is equations which will use our part for the book chapter for the optimization of hand motion recognition system, which will include all the images, which will just see this is a pre-processing part for our chapter. This is a Sobel filter and a Private filter, Canny filter, and Robert filter. This is the four types of images which will forms the code. It will use to detect how an image will capture and how it the real implementation for the Sobel filter, Private filter, Canny filter, and Robert filter. So here is a module 2, the feature extraction part. Histogram of orientation gradient speed up the robust features, soft and osteo thresholding. Feature extraction, the goal of the images, how it will extract the information, solving application based on problems. So the I told you the images will senses through the data, and it will goes to data and it will detect the images using hand motion, which will use to detect the motion of the hand, and it will follows the amount of the images data it will follows only the image segmentation and image filtering it will frequency the domain, the extract the feature of the solving the computer image problem. What feature is to be extract the application and dependent, and using development of hand motions which will follows a real virtual game and which will use without touching any hand and without touching anything, and it will follows only the gestures of, and it will follows other sensing the images which will goes to the analytical part of the can be done. So it is a here histogram of orientation gradient or HOD features which will using our part for the images which will capture and it will follows. So in the image processing feature, the point of the very much important identity the shape of the images. So how it will goes the images at form in the real implementation part on the image, which will use the how it will detect the following image. It will only goes the hand moving, which moves from one direction to the another direction. So it will uh, using the histogram orientation gradients using a possible features set to the greater precisions. It works on the uniformly spaced dense grid sloping over the contrast normalizations. So it will goes to the descriptor of advanced technique of resemblance of existing method of edge orientation histogram, which works on the overlapping of the contrast of the normalization and uniformly spaced and grids. So first thing we are going for HOG for using the image sensing and equation. It will follows the how it will detect the images. So HOG is work with the shape of the images, and it will the various backgrounds of the images, how it will be formed and how it will the motion can detect, and the standing of the motion. It will features of the works which will form. It will using the contrast and delivers the dependable factors. It provides the identical factors which will goes to two equation parts. So PPT will be showing the two images L1 normalization, L2 normalization, and L1 is square. Provides the identical factors. So speed up robust features. It is called SURF. So it will the feature detector usually will detect the 3D approaches using 3D construction. For example, 3D animations nowadays it will follows for many and animation part it is coming. So our implementation part is the 3D approach. So the HMM using the hand motion recognition using the algorithm which will use to follows our part for how it will be implementation goes on the image, and it will be we locate the recognition objects and the moving scenes tracks of the object and an extract point of the interest. The algorithm is broadly classified into three major parts. So it will be interest point detections, local neighborhood, and matching. So it will goes to the surf part for the image sensing and the robust of the features of the image. It will classify the points of the x-axis and y-axis. I told you before that images it will show. So it will goes through a data of the interest point detection for a goes to a pointing feature of the hand motion, and it will detect from the source to the destinations. So Otsu thresholding. So Otsu thresholding is a form of thresholding part of the gray level images of the binary images. So it will goes to the 2D HMM. It will best output will be shown. It will the equation will shows it will minimize that intra-class variations of the computing images. For example, system may detect only the binary coded. So our implementation part is image sense, which will goes to a real implementation part of the hand motions. The detect of the computer histogram probability of each intensity levels. So it will describe to compute the R part for the hand motions detect. It will goes to the left to right and the forward and backward detections for the images part, and it will using for the sensing of the images only using the binary image. So the images will part goes to the binary informations to the human computer interactions part, and it will the probabilities of the classes of by the thresholds computing histogram and probabilities of each intensity levels. So the future extractions, I told you that HOG features and OTC features of value and peak value. This is a form of implementation which are using our hand motions using optimization to the HMM approach using ABC algorithm. So this is a model 3 classifier, the sophisticated mathematical approach HMM hidden Markov model. So this is the Markov chain. See, it will goes the transitions. So first is the transition for the Q1, Q2 and Q3. So the initial probabilities of the initial probabilities means the input, how it will input will goes. For example, first I give the input for one data for one object, and it will inside the documents how it will go to a database and I will be inserted, and it will go to the matrix information for n into n transpositions or something, and it will see this images part. So it will the transition for the initial state to the final states. So it will goes to the image sensing for the Markov chain. So it will goes to the one form to the another form. And next step is part is the Gaussian mixture model definitions. So it is the n states. So it will shows how it will goes to the transition for the initial transition to the final transition. So red is goes to the red, amber, green, amber, and amber. And the last for the final states is going to the red. So n states observed through an observation of x. So model parameter is the equation system. So this is a part of the implementations for how it will come. So hand gesture recognition system. Our main motto is this is a motion will detect how it will the sequences. So HMM, flat left, and this is a major database part, and it will set out a database it will come, and which is HMM1 flat left, HMM2 flat right, HMM3 V shape left shape and right shape. So this is a gesture will follow the images. It will goes to a database and it will detect how it will goes the hand motions. The three basic problem evaluations, uncover the hidden part of the decoding problems, and the last is learning. This is the equation which will follows the three basic problem of the HMM of hidden states and visual states known, and it will need to be estimated. The hand which will show, see, this is a simple gif for how it hand will shows the images. Hand, see the output, the hand will shows the moving hand, it will shows the gestures how it will move it, and the second image shows the hand which will moves how it will works, the hand which will moves from how it will goes, and which the sign is to detect the hand motion recognition systems. It will part with the evaluations. It will goes to the application of the evaluation of sequence of observation, find most suitable HMM, use the other two problems, uncover the hidden parts. So this is a problem solving which will application for the real estates and the structure of the model estimations of the states using the learning problem. This is using for learning, and no analytical solutions usually solved by Baum-Welch variations. Only the equation will part the unsupervised learning and supervised learning using HMM single and multiple part for the hand motions. Some issues it will follows for Markov chain and mixture model, limitation of inputs, and scalability and learning. So this is a 2D HMM over 1D HMM. What is the comparison between the 1D HMM is an unpractical pattern recognition based on the images. See, the 1D HMM which will goes to the single dimension and it will goes to the Markov model, and it will goes to the final states and it will not repeat it. It will goes straight on a single structures. In structure 1, structure 2D HMM is this. So it will goes to the final state and it will repeat it how it will goes to the images and convert the image to the HMM in 1D HMM information made data rights, and recursiveness of forward and backward procedures which leads to the machine storage capabilities. Classification without optimization, this is the last part, and the thing is that this is a table which will shows how the recognition rate and estimation rate will follow for the image sensing problem. So our so part is to the classification which optimizes the images of the uh, sequence of the minimal optimization system. The primary objective or technique is used to reduce the unwanted transition path between the states and avoids all the self-looping of the same states. So it will go through the method for the 2D HMM. It will recognize recognition rate and estimation rate is 97.65 and 2.001 estimation rate, SVM, DTW, and ANN random tree decisions. Concept of optimization. The optimization is techniques usually used to follow the the system of the require of the improved performance measure in the systems. The projector of the works of the optimization which will use to command the compare of the images will shows the capacity irritated and network. The network will graph G which will node G is equals to vertices into edges. So special nodes of the source and the T sinks. So it will in these images will shows the vertices and edges. See these images and it will shows the graphical part for S will goes to the transition 2 for 1 and 2, and it will 1 goes to the 1 and T. So it will part of the graph is the vertices and edges which will use the source nodes and the destination nodes which will follow. So edges carry flow and edges will be maximum capacity on each. The capacited network, and network is a graph of the which nodes and edges special nodes which will follow edges which carry out, and capacity network will be for graph and images. So this is a max flow problem which is using our HMM and optimization for part for the equation which will use, and it will a binary optimization solutions mean cut is a given. So it is the equation, all the equation part will be included for the R book structures, and it will real implementation part for using the HMM, and which will use the hand motion detection, and using the systems which will detect how it will goes. Alternative explanation for the three types of arcs for the 1D binary and TVV, and it will jump to the contribution of the jumps are the contributions of the length, and it will go to the 2D 1D and 2D binary approach. See, this is all the real implementation parts of the our hand motion system. What it will goes for the sequence of the flow of the statistics parts. See, this is the part which will goes pair and length, edges cuts. Where you will get that accurately, approximately, if more neighbor are used. So classification with ABC optimization. This is a table for the classification using ABC optimizations. This will use part and conclusions in each 60. A conclusion is 60 different frames of hand images, and based on separately label them, preprocess and input data by used to edge detection of a technique. Here the edge detection done by the Sobel operator which segments perfectly rather than the other operator, since it provides a high tolerance rate of the true detections. So even the classifier has complex structures. The most possibilities of the images of the consumption or the efficiency of the systems is using the various feature extraction techniques, using the in this work histogram of the orientations and the Zernike movement provide the optimum features. Provide it can detect the predict what it's that, and it should be next stage for the features which will point can predict what it is that object has to be done for the source to the destination, and it will how it will detect from the images, and hand will motions from one part to the hand will detect the feature which will follows using the classifier or the 2D HMM, SVM, DTW, and AN. The random tree decisions are the hand motions, and in this achievement the reduction of a parameter of coefficient of the system, the various optimization techniques used we are using artificials B colony algorithm and learning algorithm and practical song optimization and sequence minimal optimization of the use in this work. All the optimization techniques will used to provide the solution of based on A, BC and ALA provide the best cost function which less iterative time. It will provide a better performance measure that than the classifier without optimization technique, and it will use the hand wheel motions, and it will detect the object which will use to interface through the environment of uh, virtual reality in the establish the well-defined sophisticated method approach for the hand motion recognition systems and among the various gestures of the human body for using the hand wheel motions how it will go to detect and the hand motion is the techniques used to the motion will sense the computer and it will detect how it will comes the provide it will provide the how images will follows the virtual reality of the gaming and some other application which will use the real implementation part. For example, uh, this is a real uh, implementation parts for future and it will works going how the hospitalities and gaming applications and more using for how it will goes to the hand wheel motions and learning part is a goes to the hand motion is a very important thing and it will goes to different methods for the HMM process for the 2D HMM and additional classification process it will go to the ABC algorithm. So our aim is to how it will be goes for the using without touching any objects. The figure will shows how it will comes. It will showing the hand will motions, the hand will moving and the motion will detect how it will come. Our second image is the how the virtual implementation of the machine learning, the augmented and the C the images will follows which is using the touching hand and the motion will detect how it will come the real implementation that this is a future part of the real virtuality of the image of the HMM process and this is the object will move on the some sources and it will detect how the human computer interactions how it will comes and see this is a part of the hand wheel motions of the machines which will using the motions and it will learn how it will come and it will uses for the motions and detections. This is a reference for we are using for the hand sign of detection recognition system. We are will move to the implementation parts or the simple implementation parts. So so it will show us the 5 images and it will process the data how it will come. See the profiler will shows the processing edge image section that list of the profiler summary as follow the images. This is the 5 images I coded and it will shows first is the real images, second is the virtual images, it will follows the canny images, private images and Sobel images and Roberts images. These are 5 different types of images which will follow the hand will shows and it will goes. So our implementation parts of the real-time application of the hand motion recognition system using 2D HMM process. So how it will goes and it will real part of the this are major programs of the which will use the HMM process using optimization of hand motion recognition system based on 2D HMM process. So our aim is to use the best probabilities of the system and it will goes these are frames or the images how it will come and the processing will show this is a list of the parts of the which will use in hand motion application systems the processing part and using applications and many applications which will use for the hand motion systems. So our part is to go into the real applications and it will using for the real-time application system using hand motion, which will detect the objects without touching, and it will using the motions, only focus on the motions on the hand gestures, using hand gesture recognition systems. So it will flows how it will goes to the works, and the real applications the works will get easier. The most possibilities is the works will easy to the human beings. Our aim is to follow the images of the recognition system based on 2D HMM approach using ABC algorithm. And I thanks all the contributors for, especially thanks to Mr. Martin sir and Jude sir for such a this project. We are working for this project, and we are real-time application which will shows for using to learn the human beings, and it will actual implementation part of the HMM or the hand motions which will follows, and human computer which will interact the data for the real implementation parts of the future. And I thanks for all the contribution, and I thankful the publishers who published this book chapters, and thankful for each everyone for this who contributed each and every one section. And this is the last part for the images which will follow, and I explain all the things. Thank you. Have a good